Alright, so 2 more lessons left. This is one of them. So we're doing determinants and Cramer's rule. Determinants not too bad whenever it's a 2x2, but when you get to a 4x4, it's a little bit tougher. So in a 2x2, we label each spot. So in the top left, that is A, top right, that is B, bottom left is C, bottom right is D. Now to find the determinant, they're going to denote it like this, and you have to know that it's going to be 2 lines around the matrix. So this is matrix A, the determinant is going to be 2 straight lines. All right, so it's very similar to the matrix look, so you've got to be familiar with what they're asking for. So here they're trying to find the determinant. To find the determinant of a 2x2, you take AD minus BC. So I'm going to take negative 2 times 3, so the diagonal, minus 3 times 1. And it's always top left times bottom right, minus top right times bottom left. So I get negative 6 minus 3, so the determinant would be negative 9 in that case. Let's go ahead and pause the video and try B. So determinant of B, I would take 2 times 6 minus negative 3 times negative 4. So that's 12 minus 12, because the negative times the negative is a positive, so it's still negative 12, or minus 12, and so then I get 0 as my determinant. All right? The determinant of a 3x3 matrix is evaluated by doing what is called expansion along a fixed row or column. The end result does not depend on which row or column is chosen. The expansion will require us to use the minor and cofactor of each element in the chosen row or column. So the minor is like the determinant without those rows or columns in it. So here's what you're going to do. It says find the minor of A12. So what I do is I get rid of row 1 and column 2 in our matrix. I'm going to make a 2x2. And the minor is the determinant of that 2x2. So I'm going to take 0 times negative 6 minus 4 times 7. So I get 0 minus 28. So the minor of A12 is negative 28. So again, you get rid of the row and the column that they say to get rid of, and you create a 2x2, and you find the determinant of it. All right. The cofactor of A13 is a little bit more complicated. So you're going to take negative 1 always to whatever this is. So 1 plus 3. You see how it's 13? I split it up into 1 plus 3, so this would be negative 1 to the 4th. All right, so if it was like 12, it would be 1 plus 2. So it just kind of depends on what the problem is. And you're going to multiply it by the determinant of that minor. So A13 means I'm going to get rid of row 1, column 3. So I have 0, 5, 4, and 6. So I take 0 times 6, which is 0, minus 5 times 4, which is 20. So you should get negative 20. So I'm going to multiply it by negative 20 to get my cofactor. So negative 1 to the 4th is 1. 1 times negative 20 is negative 20. So the cofactor of A13 means you take negative 1 always, so that power, times whatever the determinant is. So now if I want to find the determinant of the whole 3x3, here is what you're going to do. You're going to take the number that is in that spot, the first spot, so we're going to work across the top, and we're going to multiply it by the minors of that row, column, whatever it is. So 3, I'm going to eliminate this column and this row. So I'm going to multiply it by the determinant of 5, 6, 7, and negative 6. All right, then we're going to take minus. So now we're going to repeat the process, but now we're going to use the middle number. So I'm going to say negative 2 times the determinant. I'm going to get rid of the first row, second column, and say 0, 4, 7, negative 6. And lastly, it's plus. Now we're going to do the third one, 5. So get rid of that row and that column, 0, 5, 4, and 6. So I'm going to find the determinants, and I'm going to multiply it by 3. So this determinant is negative 72. Okay. Minus, this is going to be negative 2 times 28. And then plus 5 times 20. So when I do this, I get negative 216. This is negative 56, but it's minus, so it turns into, let's see, that should have been a negative 28, sorry. That's positive 86, but then it turns into a minus, so it's minus 56, and then plus 100. But again, this should have been a negative 20. Messed up my signs here. So this should be plus negative 100. Okay? So then whenever you do that, you get negative 372, and that is the determinant of that matrix. So a 3 by 3 is a little bit different than a 2 by 2. It takes a lot more steps. Pretty complicated, honestly, to get through all of it. So I just threw in some practice problems to help you guys with these. It says evaluate the determinant of each of the following matrices. Can we minimize the required number of computations by carefully choosing a row or column for expansion? So you can choose a column if you wanted to. So notice this one has a 0, and this one has a 0. I like to choose one that has a 0 in it, so I'm going to choose that row. So 9, and then we're going to do 8, negative 8, 0, 8, minus 0. So like the nice thing about this is it doesn't really matter what the determinant is because you're going to get a 0 there. Right? So when you do this, I'm going to get 9 times the determinant, which would be 64. So 9 times 64 is 576, minus 0, plus this ends up being 128, because you get 96 minus 80, which is 8 or 16, and then 16 times 8 is 128. So I get 704 for that determinant. Now this one, I can take the column because it has a 0 in it. Do you see that? All right. Or you can take the row. Doesn't really matter. I like the second row. Do you see that? It's got 2 zeros. So I can do this. Negative 2, determinant of 3, 1, 2, and 5, plus, it's going to be 0, and I'm going to have negative 1, 4, 2, and 5, and then, sorry, that should be a minus there, and then plus, it's going to be 0 again, negative 1, 3, 4, and 1. So the nice thing about this is it doesn't really matter because you're going to get rid of the zeros. So when you do this, I'm going to have negative 2 times, that would be 15 minus 2, which would be 13. It's going to be minus 0 plus 0. So the determinant should be negative 26. So one thing I forgot to mention while I was doing this is while you do this, the thing is, since we use the second row, it changes all the signs. So you get a positive 26. If you guys just want to stick to just using the top row every single time, here's that work. It's 30 minus 24 and you still get 26. I don't really care how you do it. Honestly, I would just do the top row every single time so you don't have to worry about the signs changing. Because you know it's going to be positive minus positive. That's one thing I didn't really want to mention over video. I kind of forgot about it before I started doing it. And so, again, I would just do what we did where we do the top row, and then you do the determinants of those, and you should get 26. Okay, and again, I put that work over here, and that's the work that I have on the notes. All right. So now, what you can do is you can use Cramer's rule. This is a different type of thing to solve systems. So what you're going to do is first off, we're going to make it into a augmented matrix. So we're going to have 4, negative 3, negative 5, 7, 3, and 1. All right, when you do that, first thing I want to do is I want to find the determinant of just the, what we call coefficient sign. So that would be 4 times 7 minus negative 5 times negative 3. So that's 28 minus 15, which is 13. Right, and you want to remember where that one is. So then, to find x, here's what you do. You take the solutions and you replace them in the x column. So I'm going to find the determinant of this now. So I'm going to get 21 minus the negative 5, which turns into plus 5, which is 26. So then you take your answer that you got for that determinant and you divide it by the original determinant to figure out what x is going to be. So x is going to be 2 in this case. So now I do the same thing with the y's, except for now I'm going to replace the y column. So the x column is going to be staying the same, so 4, negative 3. So I replace the y's with 3 and 1, and I find the determinant. So I get 4 plus 9, which is 13. So 13 divided by 13 would give me 1. So y equals 1. And that is how you use Cramer's rule to solve those. All right. So then in B, I threw in a 3 by 3. And here's where I would use the calculator. So hopefully, if you haven't figured it out, you can figure out how to use Cramer's rule or your calculator to find the determinants. So again, I would just use what we've been doing. So 1 times, and then be 1, 23, 0, 15, minus 18. And the thing that sucks about this one is you get some really big numbers. So the original determinant is that. And again, I would use my calculator to find it. But you should get 6,225. So then we would find the determinant of x, which I'm going to replace x with the answer column. So when you do that and you type that into your calculator, you should get 31,125. So I take that and divide it by the original one, and you get x is 5. I will attach another video to this to help you guys with the determinants on your calculator. So I'm going to do the y. So again, there's a lot of steps here. When you do this, you just find the determinant 4 times essentially of a 3 by 3, which takes forever. So what I want to do is I want to give you some time to do that on your own. And I'm going to attach another video to help you with that. If you have any questions, let me know. Your homework's going to be 10.3. So that is how you would use Cramer's rule to help you solve those. Big thing's the determinant, okay?